Hello everyone, welcome back to my channel again. Today I'm going to share with you four very frequent or very popular cases for the machine learning. And these four cases can be easily linked to the scale-up case, which means if you successfully handles a small portion of the dataset, it is optional, and it is also encouraged that you utilize a more advanced algorithm, like with the Spark handling of the dataset to actually calculate a larger portion of the data set. So basically today I'm going to show you some basic steps to analyze these documents and the possible solutions for the next step. Okay, so today is a quick overview over the four cases that you might meet in the machine learning study process. So the first one is finding similar item. The setup of the Kaggle API and also the secret in the Colab, you can check a relevant instructions. I think in Colab web page, it is also clear that you can set up the different parameter to facilitate your quoting of such a resource, so you don't need to type into the information every time you utilize this functionality of Kaggle API. And the dataset we're going to use is this one, LinkedIn jobs and skills. So basically, we're going to use two parts. One file is called LinkedIn job, and let's go to see it. This first one is called job summary. So basically, this one is about a job link and a job summary. I do not print the data frame details or statistical information here. If you are interested, you can do so. So I'm going to focus on the very shortened process. So basically, since this data set is very large, I sample 1,000 data points from this data set. So basically, they have two columns. The first column is links, the second column is job summary. And then we may utilize the vectorization method of the summaries. Basically, it just transfer these textual information into the vector space, the vector values for your further processing. If you want to go to more details, make a comment, let me know. I can go to details to explain to you. And then we can calculate the cosine similarity. So basically, this is one of the way to calculate the similarity of the different text information after they are vectorized. Okay, so you can also find the different ways, like Euclidean distance. So like Euclidean distance, you can somewhat transfer it to a similarity case, because the longer the distance, you are going to say these values are largely different. The closer they are, the less the value of the distance. You can see they are more similar. And of course, you can also use some of the other algorithm to see the overlapping of the shingles or the tokens that you set for the textual information. You can use that also to compare. Of course, that one is called Jacquard similarity. So you have so many options here. So if you want to expand this part, you can use different algorithm and compare their difference. But to be honest, at this moment, a pure numerical comparison sometimes cannot catch up the semantic information contained inside. So later, I'll show you some of the print results to explain you what I mean. Then about finding the similar job summaries. Usually you can set a threshold, right? A threshold like 0.8 is what I think is a threshold to say they are similar pairs. Okay, this is to find the similar pairs of jobs and save the similar pairs information. And eventually, the print of the similar pairs is just to print the similar jobs. So I'm going to show you several. Show you just one. Okay, so to save the time, the first one is job 4 and job 48. are similar with score 1.0. So basically, it says that these two jobs are largely similar or a potential duplication. Let's just see. This is love your job at Texas Roadhouse. Okay, and to be a grill master. Okay, I guess these are the two most important information for me to read this text at this point. Then let's see what it says. Job 84. Let's see. Yeah, it's job 84. Job Texas Roadhouse, right? Grill master. Okay, so after this quick check, I get an idea. This is potentially a correct answer. It has found some duplication. And of course, you can go on and on to check the others. So basically, the similar job search, you can use it in many ways. For example, if you want to detect the duplication or similarity pairs of the dataset, or whenever a user of the LinkedIn, the user uses this platform to search for a job. On the other side of the page, it can show a similar job. So just to guide this user to another potential candidacy possibility. So these are the ways that they can be used. Of course, you can also implement and improvise many other use to use these pairs of jobs that you found. So there are also other examples. If you're interested, you can check. And then let's check about the cosine similarity distribution. I think the pairwise similarity, the best way to visualize is by the heat map. Okay, so you just use a heat map to see which pairs are less similar and which pairs are highly similar or even duplication. As you can see, we see very few red dots, so which means that red dot or orange dots, so which means that the duplication or the largely similar pairs are less than the blue ones, the less similar ones. The other way to go into this visualization is to partition or set a section-wise partition to investigate in more details. So here we just see a very macro level summary, and if like here, I actually separate them to different ranges. You can see this is from 0 to 0.25. So you can see this is one part of the similarity information, and then we go to 0.25 to 0.5 and so on. So by separating them to different range, you can see yeah, basically if you are going to find a high similarity pairs, actually the data frame, the data set has been shrinked to a much smaller subset, so you can work on. By these visuals, it can give you some idea how you can move to the next step. Then let's check the second project. It's called market basket analysis. So basically, the project is to find, let me show the result first, find the specific rules to interpret the different keywords, let's say. For example, like this rule number 1 is saying that if a job requires leadership, there is a 62% chance it also requires communication. Okay, so this is a way to find the possible information connections between the different data points and give you a sense, like in this case, where some of the keywords are highly relevant to each other. And you can also see here communication is 2.3 13 times more likely to occur with leadership. Okay, so these are kind of information that you need to use to analyze the data set. So here, as I said, this data frame could be potentially very large. The best way for you to start with a Panda data frame, Panda package to analyze the data. It can offer you many versatile tools to calculate, to visualize. But the most important thing is that to remember, you don't want it to explode your memory. your memory budget. Like in Colab, your memory is fixed. Your local machine can handle a fixed size of the data simultaneously. So without using additional large scale calculation package or methods or database methodologies, the best way now is to sample. Okay, always recommend this. So you can also do some a data clean that is optional. But if you want to do more, you can clean also the special character and so on, right? And here is to convert job skills column to a list of lists of unique values. Then we use one-hot encoding method to create the data frame. And there is also a step to apply a priori algorithm. So basically, after implementing this algorithm, you can print out the association rules. Okay. And of course, if you want to go more detail, you can adjust the parameter, check the documentation, check the methodology description to understand it better. Okay, and eventually we see here are the rules, right? The rules are printed with numerical values. This is one thing that I like about most of the outputs of any algorithm, because you can interpret the numbers in a more direct way. So let's see some of the explanation here. It actually explains each column if, okay, the first column says if, like this one, if leadership, then communication, okay, and then the proportion of transactions that contain the if part, okay, antecedent supports and also consequent supports. Okay, you can check the details here. But eventually, if you map it to each detailed case, it actually means that if a piece of information requires a keyword, there is how much chance that it would also require, okay, another keyword, okay, about the coincidence. And about the lift is like odd ratio, I guess, about how many times more likely. Okay, so this is a second project. The third one is about link analysis. Actually, I wanted to utilize a data frame where we can have the different links of a art piece and to analyze the link relationship there. However, that data set in Kaggle is not working very well, and I have not been successfully downloading that data. So now I choose another data. So this one is called Karate Club graph. Okay, so just worth mentioning, for either you want to analyze a bunch of URL link and their relationship, or this one, the basic thing is that you need to understand the data frame should have nodes and edges. Okay, these are two most basic ones. Basically, each node has some representation. Like this one is representing a member of the karate club, and the edge representing a friendship between the club members or relationships, right? An edge between two nodes indicate that the two members are friends, or even you can define a different type of edges. Okay. And there is also a split. I think it's in default for this specific data set because it's for test purpose. Yeah, they are actually split to factions, right? So you can check the different rules of different data sets. Then let's go to the analysis of the different methodologies. First one is the function to implement PageRank. Okay, so the PageRank is actually utilizing this algorithm, calculate and eventually return there's a nodes and page rank information okay, back to the function. So basically we actually use PageRank, this function, directly on this dataset. Okay, and we need to convert these data frame, because the original data frame that is not like a table, to put it simple. And here we actually transfer it to data frame. It's like a table, so we can better analyze it. If we display the first 10 nodes, we can see here. Okay, so one node with one node is PageRank as how much value, right? So basically, you can view it as kind of importance of this page. Then visualize the PageRank as node size. Okay, so just to show its importance, and here we have the graph. So basically, we can see 0, 33, 32 are the biggest nodes, and it actually connected to all the other nodes in different ways. And all the edges, all the lines are showing a relationship. Okay, so how can we interpret this? So PageRank values output. PageRank values in the output represent the importance of influence of each node in the network. Higher PageRank values indicate more influential nodes. Okay, so basically, node 33 has the highest influence with the PageRank over this value, and so on. So in summary, node 33 is the most central and influential node in the club. So we can interpret it in different ways. For example, like in the social network, okay, in a social network platform. If they find using this type of way to find several people in a hypothetical group of people, users, and this center person is very important, we can actually implement some algorithm. For example, your strategy of of the advertisements, your strategy of marketing could potentially change, because once you get the attention of the single person, this single person can share or can spread this information in a faster way than the other persons. So they are kind of identify the key personnel in your user base. Okay, this is one type of the interpretation. It may not be very robust, but it can give you some initial idea. And we can also see here, okay, node influence, node with higher rank page scores are considered more influential, more important in the network. Okay, and also we can see the network centrality. So to find the most important node, you can have different ways to handle such information. The last one is about the plant leaf recognizer. To put it simply, it is an image recognizer problem. So for image recognition, I think we have so many existing tools in TensorFlow. And also to classify these photos, I think is always a very interesting task, because classifying the photo, I believe it can also extend to other calculation or algorithm about images. Okay, it's like object detection, different ways in machine learning, automatic driving, and so on. I suppose I have not yet touched the automatic driving part, but yeah, here we are. Let's see how it goes. So basically, this is the data frame I found. It's like flower photos. Okay, so basically, the first thing you need to do is to extract this data, right? So basically, it extract this data and create a generator. Okay, this generator, image data generator, is actually directly using the TensorFlow package. Okay, so if you want to go to more details, I can also do another video to explain you how this in detail works. So basically, it actually needs you to set up different parameters, okay, according to your needs. Then you can set up the train data generator, okay, and also the validation data generator. So basically, it's like any machine learning model. You can set training set, validation set, test set, and so on. So here I do not set the test set, but I have the training and the validation, okay, to do the basic calculation and to see how the loss and also the accuracy evolves. Then I build the model. with the MobileNet V2. This is a specific model for image classification. And the model use here the base model, then like the global average pooling 2D. Okay, these are different parameters set to the model. Okay, so basically, if you are using a neural net, is a different story. You need to set different types of parameters, function names inside. Okay, so here is also the layer. Okay, and the activation function is value, and also there is also a dense layer about generating the number of classes, and the activation function is softmax. Because in general, the eventual target is to classify, to tell you if this flower is this flower or another type of flower. And when we come to the compilation of this model, like the optimizer, loss function, matrix, these are all parameters we need to set here to determine how you run this model and get the result you want. And I also add some optional steps here it is a iterative process when I use them to facilitate my debugging or stop some of the unexpected problem of the training. Then about 1 hour, I'm using Colab free version about 1 hour to actually run this code. So if you are running the previous three projects, I think the first project took about 20 to 30 minutes. It depends. But this one is about image. It takes the longest. It's almost 1 hour. And here we can plot, right? Plot the process of the whole training process. We can see that the model accuracy, about the training part, it goes higher and higher, but the validation part is going down and rebounds a little bit, but still not as we expected, right? So the model loss actually in the validation datasets, the validation partition, it actually goes very high, okay, higher and higher. So we understand this, and let's try to use this model, okay, to test, to generate the classification results, and we can see how it goes. Okay, I'm not going to go to the details here. If you have any question, you want to go more detail with them, you can do it in future videos. So here, after the training, we get these results, right? We test for, like here we show 9 images. We see the first one is wrong, right, wrong. So basically we have 2 images classified as wrong category, the others are correct. Okay, not so bad, but always be cautious. If we have such problem in the machine learning area, always try to regularize the model, okay, to add a penalty term to actually at least make sure that the validation set or the test set that the loss will not explode, okay, higher and higher, and accuracy could be guaranteed. Okay, so later I'm going to show you additional ways to make this work. Basically, it's just one single regularization method. So here we can see we have different steps summary here. So this one just stops here. I'm going to show you some further improvement. So here, let's see how we can improve this model. So the first part is still the normal training, and we got the mapping or the graphical information of the model accuracy and the model loss, right? So accuracy during training is very high, and the validation part is very low, relatively low. And the model loss about the validation part actually explode somewhat. And let's see. So using this initial model, let's see the first two are the first 3, 4, 5, 6, 6 images out of 9 are wrongly classified. But remember, this does not represent the whole dataset or the dataset that you sampled. Okay, this is just some quick example. So after checking the original training and validation results, let's see here, we're actually doing some tests to see the prediction, if the prediction is correct or not. As you see here, we have many images wrongly classified. Okay, again, if you want to investigate the statistical property and go deeper, always stop and go deeper of the algorithm, calculation method, and the theory behind. And here we come to the final part. In the final part, we actually add the regularization term in here in the model part, and for the first dense layer setting we get the L2, okay, regularization. So in my other project, like when I did the neural network project, I did some tests about L1 and L2 and the mix of them, different regularization methodology. Basically, you can see different results. Here, it started with 0.01, the regularization value. It actually already improved the model. And if you want to try the other parameter, please use a for loop or other methodology to test it. Okay, so the other part does not change. Let's see how the graph change. So as you can see now, the train and the validation accuracy, it actually improve, and they have some synchronization here. They don't diverge from each other very much. Then we can see the model loss, both the train and the validation drops, okay, after the epoch. So this is a improvement for my project. Of course, if you are not satisfied with this one, try different regularization or even change the overall prediction model structure. Okay, so let's see here. Okay, luckily the some of the predictions see here are all correct, but we cannot say this model is 100% correct, because as you can see, the train and the validation accuracy is around 85% to 87.5%. Okay, although the training accuracy could even go higher, but it does not actually have a real impact like on the validation set, or even if you set another test set, either with new images or the existing image, but you partition them, you're going to see some variation from the current version that you see. Okay, but the general principle is that we need some convergence. We need the improvement of accuracy and also the dropping of the loss. Okay, so here we finished the final one. And remember about the regularization, it is very important. You use L1, L2, or combination of them. Do some tests to get some visual understanding of them, and then you can better implement in the future projects. Okay, so today I have finished all the project introduction. So basically, these are very fast without going to every detail introduction. I wish you enjoy it. If you have any question, feel free to let me know, and we can discuss. If you want to go deeper to some concepts, we can also do that. There is no problem. But really, I need your feedback. So basically today on the project, I think on the small data set range, we sampled 1,000 data and so on for different occasions. If in the future you want to do these analysis on a huge data set, it will require like the Spark and the different ways to handle them. In the future, if we got a chance, we can we can also discuss some of the parts. But at this moment, for a small, limited data frame, do try different algorithm, try different models, visualize them, and then get more insight. So you can move to the next part. Machine learning at this moment, for all the courses I learned, I checked about generative AI, AI agents, about machine learning. I think one thing are in common is that no matter how you change different machine learning algorithm and so on, always you need to focus on the accuracy and loss. You need to check if the different parameters are set well. You also need to make sure that you could better understand a problem and its solution. For example, like years ago, CNN was used for image classification, but maybe now it is too antique. But if you are going to adopt a new algorithm, it's better that you see the difference between the different types of algorithm. So when you implement them, you can see sometimes the different results. Why that? Okay, these are just my quick suggestions. So wish you enjoy this video. If you like my video, give it a like, leave a comment, we can discuss. And if you like more updates like this, feel free to subscribe. So see you next time. Bye bye.